Gracias. Alright guys, now since I haven't done enough examples on this, let me do question 1 here. Now before I do, how did you guys find the test yesterday? Is it too easy or difficult? Easy, right? I mean, you should look back at the solution. You think it's not. I mean, it's not. It shouldn't. It's not. It should be. I mean, a lot of people got full marks. Think about 20% of the class got 20 out of 20. About 50 people got full mark. I think that's too many. But I think the exam will be more. So exam will be a little bit more tricky. So try to be prepared for that. And the next 2 weeks are going to be revision classes anyway. So the next we got 2 weeks of revision classes starting next Tuesday. So bring any questions you have for the final exam. You can bring it. Okay. Anyway, let me show you how to do. Let me show you how to do this question now. I know it's been a long time since I did this NP Llama thing. We did this stuff before the Easter break. That's about 4 weeks ago. So I know you probably forgot what I talked about. Right. So we have 3 IID observations from a Poisson distribution with parameter lambda. And we want to test whether lambda is equal to 1 versus lambda equal to 2. And the question is asking you to find the most powerful test, which basically means that apply the NP lemma and find the rule for rejecting the null hypothesis. Right? If you look at the lecture notes, guys, by the Neyman-Pearson lemma, we reject the null hypothesis if do you guys remember where this comes from? This is stuff we did before the Easter break. If you look at the last page of the lecture notes, the printed lecture notes, you will see this. This is the Neyman-Pearson lemma, which says that you reject the null hypothesis if the ratio of the likelihoods at 1 divided by 2, right, is less than a constant c, right? Yeah. Come on, guys. You should just look at this. If you look at the lecture notes, you will see where this comes from. Okay. Let me put my glasses. I think you can't. Having difficult to say things. Okay. Now the likelihood at 1 is just the product of the PMF of the Poisson distribution so this is the likelihood at 1. So what I've done is to take the product of the PMF of Poisson at lambda equal to 1, I from 1 to 3. Right? You see what I've done, guys? So this is the likelihood at 2, this is the likelihood at 1. Okay? Now, a few things cancel. This guy here cancels out with this guy. Yeah, so what you get is the following. In the numerator, you get E of minus 3 times this guy here. 1 to the power anything is equal to 1. Okay, so this also disappears. Okay, so you have e to the power minus 3 in the top. In the bottom you have e to the power minus 6 times 2 less than a constant c. Okay, yeah, right. So this becomes yes. Okay, now I'm going to take this guy. I'm going to take this guy here to the right hand side, so it becomes yes. And the next step, I'm going to take the logs both sides. So if you take the log of the left and the log of the right, you get minus yes. And finally, I'm gonna divide both sides by minus log of 2. Now minus log of 2 is a negative number. Remember, when you divide by a negative number, you need to change the sign. So the sign less than becomes greater than. Okay. Are you guys with me so far? Yeah. Right. Now, for the sake of notation, let me call this guy here some simple say k. I mean, I can call it any other name, but just for the sake of, let me call it k. Okay. So what the story so far is that by the Neyman-Pearson lemma, we reject the null hypothesis if the sum of the 3 observations is greater than a constant k. Now the next question is, how do we determine the value for k, guys? So that's the next question I'm going to answer to you. All right. To determine the value for k, I'm going to use what is given in the question, guys. You should read it. It says the value for alpha is 0.1. We are told that alpha. Remember, alpha represents what? Alpha is known as the probability of type 1 error. because I'm sure you remember this from before the Easter break. We did this, guys. So the probability of type 1 error is equal to 0.1. Yeah. Now we know that type 1 error is the probability that we reject H0 when H0 is true, which is lambda equal to 1, equal to 0.1. Okay. Now, according to the Neiman-Pearson lemma, we reject the null hypothesis if x1 plus x2 plus x3 is greater than a constant k. Okay. Let me remove this. Okay. Now we know that x1, x2, and x3 are independent Poisson variables. Now, one of the properties of a Poisson distribution is that if you sum independent Poisson variables, then the sum is also Poisson distributed. Yeah. So in this case, the sum of these three guys also has a Poisson distribution with parameter 3 lambda. Now you may wonder how I get this 3 lambda. 3 lambda is just the sum of the parameters of the 3 Poisson variables. So lambda plus lambda plus lambda, right? So the parameter of the Poisson distribution is the sum, right? Okay, so this becomes here at this step I've subbed in lambda equal to 1 into this, so I don't need the conditioning anymore, right? Okay. Now this equation, we need to solve this equation here for the value for k. Now this is something you cannot do it by hand. So to solve this equation, you need to use some kind of a computer software. So it must be solved numerically using some computer. So this equation here can be, there are programs like R. I'm sure some of you are already familiar with R. So you can use the R package to solve this equation for the value for k, right? So the conclusion is the following: that the conclusion is that by the Neiman-Pearson lemma, we reject H0 if right. So this is the conclusion to question 1, right? Okay. Is that clear with you, all of you guys, or not? Or if it doesn't make sense, just raise your hand, guys. Or that's really answering. So that's done. That finishes question 1. So that completes question 1, guys. So if you have to try and do question 2, guys. Please try to apply the same method to do question 2. Russia. Oh, you're okay?
Yeah, absolutely.
No, I think the syllabus is finished this week. So next 2 weeks I will do revision classes for the final exam. Yeah. I'll send you guys an email later today or tomorrow. So, yeah. So we have all the lectures next week and the following week, and the exam classes will be for revision. Yeah. So all the questions you have this week. Yeah. And you guys do social interpretation if you understand, it's okay. If you don't understand, ask me.
Yeah.
Alright guys, I mean it's similar to what I did in question 1. So you should understood question 1. You shouldn't face problems doing this. Alright, so let's see how we can do this. Okay, so this is question 2. You have x1 to xn IID normal with parameters this and this, and we want to test this versus this, where we are told that the sigma 0 is less than sigma 1. Okay, sigma 0 is less than sigma 1. Okay, that's important. So once again, you start by saying that by the Neyman-Pearson lemma, which is on the last page. If you look at the last page of the lecture notes, you will see this, right? We reject H0 if the likelihood at sigma 0 divided by the likelihood at sigma 1 is less than a constant C, right? Now here we have data coming from a normal distribution, so the likelihood will be okay. So this is the likelihood at sigma 0, and similarly the likelihood at sigma 1 this is the likelihood at sigma 1 less than a constant C, right? A few things cancel, namely this one and this one cancel out. So what you get, guys, is the following. You get this, you get this in the top, and you get this in the bottom, less than a constant C. I mean, it's important. I mean, I saw yesterday in the test that some people can't even simplify likelihood functions, and it's important. It's very, very important that you simplify likelihood functions correctly. If you get that step wrong, then everything else is wrong. So that's I know a lot of people did very well yesterday, but some people can't even simplify, go from this step to this step. They can't do it properly, and anyway, so that's why, I mean, if you look at the course website, I put some mathematical identities. You should look in my website for this course. I put some mathematical identities you can learn to simplify likelihood functions. So all right, so now this simplifies to This simplifies to this, right? Yes. Now the next step, I'm going to take the log both sides, the left and the right. So if I take the log of the left, you get this is what you get. You should take the log, right? And in the next step, I'm going to divide both sides by this guy here, right? Now the first thing you must note is that whether is this factor here, is this a positive or negative? It's negative, right? It's negative because remember what? Because sigma 0 is less than sigma 1. Because of that, this factor is a negative number, right? So when you divide by a negative number, once again, when you divide by a negative number, the less than becomes greater than, right? So it becomes 2 yeah, this is what you have. And the final step, because we want to get the answer that is wanted in the question 2, I'm going to divide both sides by sigma 0 squared, because that's the answer we are looking for. So it doesn't. All right, so this is part 1. So what I've done here so far is part one of question 2, right? Because the question in part 1 was to show that we reject the null hypothesis if this guy is greater than a constant. Now let me call this constant here some name, right? Just for the sake of simplicity, let me call this k, right? So what we have shown so far is that we, by the Neyman-Pearson lemma, we reject the null hypothesis if this guy is greater than a constant k. Yeah? Yeah? Okay. Right. The next part 2. Are you guys okay with this or not? Yeah? Good. Okay. So let me show you how to do now. Part 2 of question 2 is to determine the value for k, and you are told that alpha is 0.05. Now remember one more time, alpha is the probability of type 1 error. Is 0.05. Type 1 error is defined as you reject the null hypothesis when H0 is true. So that is, we reject the null hypothesis if this guy is greater than k, given that sigma is equal to sigma 0 is equal to 0.05. You know where this comes from part 1, right? This is the rule for rejecting the null hypothesis. This is the null hypothesis, sigma equal to sigma 0. Now let me ask you a question. I know you guys have been revising a lot for the test. Can you tell me what distribution will this have and why? This is stuff we've done in the notes. What distribution do you think this has? given that sigma equal to sigma 0. This will have Come on, guys. You don't remember? This is equation. You should look at equation 75 in the lecture notes. You will see that this is the chi-square distribution with n degree of freedom. I don't know whether I have the notes with me. Let me share. Let me see if I have the notes. I'm sure. Do you guys have the printed notes? You can look at it. I don't think I have it here, but anyway, yeah, I'm sure you have a copy of notes here. Let's see. Here. You see, this result here. Do you remember this, guys? This is equation 75. It says that the sum of this squared has a chi-square distribution with n degree of freedom. But in our case, the mu is 0. So this is the same as what we have with mu equal to 0. Right? Okay. All right. So what this implies is that what this implies is that k must be the percentile of the chi-square distribution with the probability exceeding being 0.05. So in other words, you should have this as the PDF of the chi-square distribution. Then the point where this area here, the area to the right, is the 5% area. If this is the 5% area, then this point here, guys, is equal to this, right? So it's the point on the x-axis of the PDF where the area to the right of the point is the 5% of the total area, right? Which is this one. All right. So that answers part 2 of question 2. Unless you don't. Is anybody who? Well, is anyone who did not follow this? This is clear or not? Are you guys okay with this? Yeah? Yeah? Okay. That's part 2. Now part 3 of question 2 is asking you to, can I take this away? Oh, let me leave it here. Okay. Part 3. So part 3 of question 2 is asking you to find beta. Remember, beta is what? Beta is the probability of type 2 error. Right, so it's the probability that we accept the null hypothesis when sigma is equal to sigma 1. Right? Now, we know that we reject the null hypothesis if the sum of the xi squared divided by sigma 0 squared is greater than k. So we will accept if is less than k, and we already know what the value for k is. This is the k. All right. You see how I got this, guys? This is the opposite of rejecting, which is accepting. Yeah. Okay. Now, to determine the distribution of this, you should be a little careful, because the conditioning here says that the true value for sigma is equal to sigma 1, which is not the same as sigma 0. So what should you do? I mean, we did this kind of stuff before, guys, if you remember. What we should do is the following, guys. You should replace sigma 0 by sigma 1, because sigma 1 is the true value for sigma, not sigma 0, right? And because I have done this, I need to multiply it by the same thing and keep the sigma 0 squared here. Do you see why I'm doing this? Because we are conditioning on the fact that the true sigma is equal to sigma 1. So we should keep the true value for sigma here, which is sigma 1, right? Now I'm going to take this guy here to the right hand side. So this becomes yes, yeah, and one more time, by referring to equation 5 in the notes, you can say that this guy conditional on the fact that the true sigma equal to sigma 1, this must have the chi-square distribution, right? So once again, by equation 75, by equation 75 in the notes, this guy must have the chi-square distribution with n degree of freedom, right? Now we don't need the conditioning anymore, because we have used the conditioning to argue that this must have the chi-square distribution, and therefore it's no longer needed, right? So this is the answer. This is the answer to part 3, that is the probability of type 2 error. Yeah. Is that clear, guys? I don't know. All right, sir. Yeah, good. I know. I mean, we will because the syllabus for this course has now been completed. So the next 2 weeks, week 11 and week 12, we will do lots of revision exercises. And so when you guys come next week, please bring in all the questions you have on the stuff you've done. And you can also try to have a look at the past exam papers on my website. I listed the past 10 years exam papers, and you can go through all of them and ask me any questions you have. I'll be happily do them on the board, or on the scan, on the visualizers. Okay. So please, of course, you can also send me any emails any day, any time. Now I listed the. I hope you found the test yesterday not too hard. I think the results show that it was quite easy. The average is about 75, which is too high for this school. Don't expect the same with the final exam, though. Anyway, I brought the test papers here. They are on the first row here. They are arranged according to your surname. It is that. So could you please come and collect your test paper? Thank you. And if you have any questions, just ask me on the test. And also, if you haven't signed the attendance sheet, please could you sign the attendance sheet? Thank you. Thank you. Hi. subing the value for sigma 0, sigma 1, and it's all given in the question, and then you can work it out. You can work it out using computer software. This is not possible. In the exam, it's okay to do that. Okay.
And just why, like, you know, when you change that to chi-squared, why isn't it n 0.05 on that one? Why is it just n?
Because it's a random variable. This is a random variable, not a value.
Okay.
So this k is a number. It's not a, so that's k is equal to this because this is a percentile, it's a number. Whereas what you have here is not a number, it's a random variable. So that's why I did not do it by chi-squared n, which is a random variable. Yeah. Do you follow? Yeah. Yeah. Thank you. Right. Means the point on the x-axis for which the area to the right hand side is 5%. That's why it's 0.05. Yeah. So so suppose the PDF of the chi-squared n looks like this. Then the point along the x-axis to the left, to the right of which you have 5% is equal to this. Yeah. That's what it means. So you got a question on the test.
Is that a 4?
What did you get? A 6. You got 2, 4. 2, 4. Just a minute. Yes, okay, I'll change it. Sorry for the mistake. Now can I give it back to you next time? Yeah, we have a question too, sir.
I was just wondering what was missing on this part. I went over the pages.
Yeah, I know. Okay, I'll check this again. I'll check back to you. Sorry about this.
It's okay.
You say that.
It might be a mistake.
Yeah, maybe you may want to do Sorry. I mean, did you find this course? You said you liked the course. I mean, last time I talked to you. Yeah. I'll just come back from the yeah, I mean, just I'm trying to help you, man. I can help you in any way, you know, to improve your performance. Let me know. I mean, I'm prepared to give you a personal tutor if you like, if you think it will help you. Bonus score. You can get 2 extra marks if you do that right. Yes. So once you have I send it to you? Yeah. Try and submit to me before the 22nd of May. And then any kind of tutor you need, I'm prepared. Thank you. Yes, okay. You got your papers back? Okay, thanks.